Okay, so now we're going to be looking at reverse chain rule. So as I said, in integration, we always try and write them as sums, and then we try and integrate. However, there are some situations where you can't actually write them as sums, and there might be another way. Okay, so let's think about differentiation first. If you had 3x squared plus 4 to the whole power of 5, now the chain rule was you just pretend that whatever's inside the bracket is one variable. So you've got 5 times whatever's in the bracket to the power of 4 because you've taken 1 away from the 5. And then you times by whatever's inside the bracket, the derivative of what's inside the bracket, which is simplified to, let's say, 30x bracket 3x squared plus 4 to the power 4. Okay, so what we have here is this is kind of, okay, a multiple of the derivative of what's inside. Okay, so although you've got two products here, what's in front is the derivative of what's inside the bracket. And so when that happens, we apply the reverse chain rule. So let's look at this example here. So here we have x squared plus 3 to the whole power of 5. Okay, there are two things being multiplied, and I can't write this as a sum. Number one, I can't write this as a sum unless I expand it all and then break it up. Okay. What we can, however, do is we recognize that the 12x, okay, there is a multiple of the derivative of what's inside. So if you differentiate what's inside, you get 2x. So I can see that 12x is basically 2x times 6. So I can integrate this by applying the reverse chain rule. So ignore what's inside, pretend it's just like one variable. And I'm just going to add 1 to the power, okay, and leave what's in the front there and divide by the derivative of what's inside. So I'm going to divide by 2x and then the plus c. So that will simplify to, so the x's cancel out and I've got 6 bracket x squared plus 3 to the power of 6 plus c. Now, what you can do is you can check that you've done the right thing by differentiating again. So, sorry, that's 2, not 6. Okay, so when you differentiate this, you will get what we started with, and that's the way you can check that your answer is correct. Now, we'll do one more example, and it's again in the similar vein. So if you have a look at this, I'm going to first write it in power form. So every time you see square roots, yes, Adam.
Why is 12x divided by 2x is 2?
Yeah, sorry, it's divided by, okay. It's 6, not, just 1 second. Let me just change that.
I think it should be 12x divided by 12x.
Yeah, I just, you know what I didn't do? I'll tell you what I didn't do. I didn't divide by 6 as well because I have to divide by 6 as well as 2x. Does that make sense, guys?
Yep.
Yeah, I have to divide by the power as well as the derivative. Okay, so which will give me just this. There's no constant in front. So let me just check. Okay, that's really good that we had this problem. So we can see when then I multiply it out, I will get that. So I'm going to have 6 bracket x squared plus 3 to the power of 5. Okay, and then I'm going to times by the derivative, which is 2x, and then that simplifies to 12x x squared plus 3 bracket to the power of 5. So this is the answer. I apologize. So you have to divide by not just the derivative, but also by the new power. So, you know, when you have x squared and you integrate x squared, you go x to the power of 3 and divide by the 3. So that's what what I missed over there. Okay, so hopefully you guys caught that and hope it makes sense now. Anyways, we'll do another example and you'll see. Okay, here we go. So first thing, I'm going to write it out as to the power of a half. Now, this is the tricky part a lot of the time, not knowing whether you're doing trig products or whether you're going to be doing reverse chain rule or which way to go. So first and foremost, when you have something like this, you have a bracket to the power of something. The first thing I want you to check is if I differentiate what I have in the bracket, will I get what is there? Okay, now if that's the case, then you know that it's reverse chain rule. So sine 3x, when you differentiate, is cos 3x. Okay, so we know that we are going the reverse chain rule route. So I'm going to add 1 to the power. So half plus 1, it's 3 over 2. I'll leave that there for now. So I've got to divide by 3 over 2. So I'm going to be timesing by 2 over 3 because dividing by 3 over 2 is times by 2 over 3. And I've also got to divide by cos 3x, okay, which is the derivative of what's inside. It's not just cos 3x, it's 3 cos 3x, okay? So now, if you just move to the side here and differentiate sine 3x, okay, we know it is cos 3x times 3. So that's why I have the 3 cos 3x over there. So I divide by the new power as well as the derivative of what's inside the bracket. And then we've got the plus c. So what happens here is the cos 3x will get cancelled out. And I am going to be left with 2 over 9 because the 3's multiply sine 3x to the power of 3 over 2 plus c. Now we can check by differentiating that we've done the right thing. Okay, so 3 over 2 times 2 over 9. And 3 over 2 take away 1, which is a half. And then times by a derivative of what's inside, which is 3 cos 3x. Okay, so the 2's are cancelled out. That 3 is cancelled out with another 3, and that one's cancelled out, which gives me square root of sine 3x cos 3x. So you can see that that's what we had originally. Okay, now